Example 6.1 on page 138. Make sure you have that open in front of you and have read through it before you go any further. As ever, we're going to draw a little sketch of the situation. A person's pulling a 50 kilogram crate, so 50 kilograms, 40 meters along a horizontal floor with a constant force of 100 newtons at an angle of 37 degrees. Now don't forget the 37-degree angle is a 3-4-5 triangle. The floor is rough and exerts a frictional force of 50 newtons. So there's our friction is 50 newtons. As asks to determine the work done by each force and the net work on the crate. So there's a couple of ways of going about this. The only component of the force that does work is the component of force that acts in the direction of motion, which is horizontal. So the component of this force Fx is F cosine of 37 degrees, which, because 37 degrees is a 3-4-5 triangle, that's basically 100 times 0.8, so it's 80 newtons. And it's pulled a distance of 40 meters. So the work done by force F is the x component multiplied by the distance it moves, 80 newtons times 40 meters is 3,200 joules. The unit of force, newtons, the unit of work is newtons times meters, which is given the special name joules after Henry Joule, who did a lot of work on work and energy. So that's the work done by the pulling force. The frictional force also does a certain amount of work. And the key thing here is that the frictional force is in the opposite direction to delta x. Delta x is forwards, the frictional force is backwards. So it's the frictional force times the distance moved. And the frictional force, because it's in the opposite direction, is negative, so it's minus 50 newtons times 40 meters, which is minus 2,000 joules. The minus sign there, negative work, what that means is that that force is actually working to take energy out of the block. It has a certain amount of kinetic energy due to its velocity, and friction is slowing it down, reducing its kinetic energy, and basically dissipating that energy as heat. So the minus sign tells us that the object that's being acted on by these forces is losing energy. And then the net force, the net work done, is just add up the work done by the two forces. So it's the work done by the force plus the work done by the friction. 3,200 minus 2,000 is 1,200 joules of net work. 3,200 joules of work done on the block by the pulling force, and 2,000 joules of work pulled out of it again by the frictional force that's opposing it. Another equivalent way of getting at exactly the same thing is to say, well, what's the net force acting on the block? And it's our pulling force minus the frictional force, which is 80 newtons minus 50 newtons, which is 30 newtons. The net work, therefore, is the net force multiplied by the displacement. 30 newtons, 40 meters, 1,200 joules. Same answer. Two different ways of getting at the same thing. You can calculate the work done by each of the individual forces and then add up all that work to find the net work, or you can find the net force that acts on the object, multiply by the distance, and that gives you the net work. And that work that's been done is equal to the change in kinetic energy of the block. They're the same thing.